Okay, so in this video, we're going to be learning how to interpret graphs. So we're going to be learning about maximum points. We're going to be learning about where points are increasing. We're going to be learning how to read points on a graph. We're going to learn where a graph is positive and negative. But before we get into that, let's just go over some key definitions we should be familiar with. So a root. So remember, the root of a function is the point where a function crosses the x-axis. So for example, we know this with quadratics. So see how this quadratic passes this point and that point. They are the roots, right? The y-intercept is where it crosses the y-axis. That'll be that point right there. It crosses the y-axis. At that point, that's called the y-intercept. The slope, remember, the slope is just the measure of steepness of a line. So remember, if the line is really if the slope of a line is a big positive number, it's very steep. If it's a number kind of middling to zero, it's going to be very not as steep. If it's zero, it's going to be a flat line. And then same thing here. If it's a low negative number, it's going to be not as steep. And if it's a high negative number, it's going to be very steep, pointing downwards, right? Turning points. So turning points is where a graph changes direction. So we're going to be learning about them now in a minute. So where it's going from increasing to decreasing or vice versa. And then maximum minimum points are just the biggest or smallest points, on the highest point or the lowest point on a graph where a function reaches. And then there's local maximum and local minimum. We're going to learn more about them when we come to cubics, but it's the same premise. It's just with the lowest point and the highest point of a graph. So how do we read graphs? Like, how do we do it, right? So this is the thing a lot of people find really confusing. They're like, I don't know what we're doing. If I've given an x value, if I'm given a y value, I don't know what I'm doing, right? So you just need to learn this off, right? Because it'll make your life so much easier. If we are given an x value, for example, it will say find the value of a function where x equals -4. If we are given the value of x, or right, we're given something like this, like f of -4, right? That -4 is in the brackets, therefore it's an input. It's an x value. I'm given the x value here. If I'm given my x value, I just go to my graph. I go to -4 on my x-axis, which is here. Then you just go up or down, wherever, depending on where it'll hit the graph. So you go down, and it, bing, hits the graph there, and you go over and read the corresponding value, which is, in this case, 5. So you draw a line vertically from the given value of x on the x-axis until it intersects the curve, and then horizontally until it intersects the fx-axis or the y-axis, right? And then same thing kind of goes for when we're given the f of x, or when we're given f of x or a y value and we want to find the corresponding value of x, we now draw a line horizontally, right? So, for example here, this could be find when f of x equals 2, right? Or it could ask us when y is equal to 2, right? So this 2 here is outside my bracket, so it's an output. If it's outside the brackets, it's an output, right? So f of x equals 2 or y is equal to 2. So I go to 2 on my graph. See here, I'm at 2 on my graph, and you draw a horizontal line that is parallel to the x-axis, like so. Bing. And you just make note of the 2 points that it intersects the graph at, and you go down, and then you see, oh, this one intersects at x equals -0.6, and then this one here intersects at roughly 3.6, right? Now, it's very important in your exams, right? You are given a margin of error. I think officially it's, a leverage of, 0.2. So like you do have some wiggle room anyway. If you said here 3.8 instead of 3.6, like, you're not going to be penalized marks for it. Now, if you said something crazy, like you looked this here and said your answer was 4, ooh, like, ooh, you know what I mean? Like that, ooh, like that's okay. That's a bit too far out now. You know what I mean? But as long as you read your graph correctly and read the points correctly, you will get the full marks and you do have that bit of wiggle room. Now, in the case of you plotted your function wrong, if you plotted your function wrong, remember, if you plotted your function wrong and then you asked questions on that function like find this point, blah, 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 and you found the correct values for your incorrect graph, meaning like this is the wrong graph, but you did everything else correct, you got the wrong answer, but it was right for that graph, you're still getting your marks. Right, so that is how we read points. Just remember, if we're given X, we go down. If we're given Y, we go across. I don't have a little idiom thing to help remember it, but you just have to, remember it. Right. Other things to note, right? So the nature of roots of a graph, right? If a function does not cross the x-axis and it has a turning point here, so this is actually known as a turning point, right? So it's the point where the graph, see, it's going down and then it turns here and goes up, but we'll get into that in a second. But if a turning point, right, if it has a turning point and it hasn't crossed the x-axis, it has imaginary roots, right? If it touches the x-axis once, it only has one real root. We can also call that equal roots. But you don't need to get into too much detail in that in GeniusSearch and or higher level. Same here with this imaginary roots. That's more for leaving search, right? And then see here, it passes the x-axis twice, so it has two real roots. That's just something just to be aware of. Right. So where a function is positive or negative. So a function is said to be negative when the curve is below the x-axis. It is negative because f of x or the y values are negative. So it's where y is negative. So that's why we say the graph is negative, because it's below the x-axis, i.e. we're getting into the negative y values. So here's a function here. The graph below is the graph of the function 6x squared minus 3x minus 18. What are the range of x values for the function? What range of x values is the function negative? What range of, I think that's meant to be x values. Sorry again. What range of x values is the function positive? So I've already kind of did deliberately here. Here's the graph. I marked in where it's positive and negative. So here's my x-axis, right? And we see here, my graph is negative, right here, right? It's below the x-axis between these 2 points, and any point to the right of it here, right? Any point to the right of it, it's above the x-axis. So we say these are positive. So above x-axis, positive. Below x-axis, negative, right? So how can I say where it's negative? Right? Well, I can say it's negative, right, when x is greater than this number, but less than this number. So when x is greater than minus 1.5, right, but less than 2, right? So it's greater than this point, but it's less than 2. Then the graph is positive, right? It's positive when x is greater than 2. So when x is greater than 2, the graph is positive. And when x is less than minus 1.5, then my graph is positive again. So this is a really kind of tricky thing people get confused on, right? But that's just positive and negative functions, right? So it's positive above x-axis, negative below x-axis. Finally, turning point, increase and increasing, decreasing function of a function. So a function is said to be increasing, decreasing. You can kind of get the gist of it here, right? So when you're reading the function from left to right, it's literally decreasing, right? It's going down, right? So it's going down. It's yelling timber, right? You get the point, right? So down, 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 down. Oh, what's happening here? We're going, just like Loreen in 2012 Eurovision, it's going up, 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 up. Euphoria. Anyway, There's a little song for you. So it's decreasing here between that point and this point, but it's increasing from here to here. So see how it changes direction at this point here. Then it starts going down, but then it starts to go up. So this is called a turning point. Right, you don't really need to know the terminology per se, but that's just the turning points, right? And turning points are usually max and min points. Right? So this one has a minimum, so this minimum point, this turning point, so this is where the graph goes from decreasing to increasing. So it's very simple, right? Just imagine imagine you're walking along it, right? It's going down. You're going down. You'll read from left to right. My graph is going down, but then it goes up. So it's decreasing from x is minus 5 to x is minus 1, but then it's increasing from x is minus 1 to like x is 3, right? And that's it. And then the minimum point here is minus 1, 6. So let's look at a real life quadratic graph now. So the height h of a tennis ball thrown into the air is given by the formula. H of t is equal to 10t minus t squared, which is graphed below. So it's graphed for us here. Gorge. Use the graph to estimate the answers to each of the following. What is the height of the tennis ball after 2.5 seconds? So 2.5 seconds. So I am looking at my x-axis, right? Because my time is my input, right? And it's my x-axis. So I go to 2.5 seconds on my graph. Remember, so I'm given, right? I'm given my x value here. So go to 2.5 on my x-axis. I go up, ding, it hits off there. I go across, boom. So my height is roughly going to be equal to 19 meters, right? So my height is equal to roughly 19 meters. Right, so I'm given my x value, so I draw a vertical line. At what times is the height of the ball 12 meters above the ground? So 12 meters, that's my y value here. That's my y-axis. So I'm given my y value, so I want to find the times or my x values here. So I go to 12 here, ding, go across. So remember, you go to 12 on your x-axis, draw a parallel line. If I can. Oh no! Oh, there you go. Ding, ding. Oh, yeah, there you go. Finally. Right, so it hits here, and it hits here. So, my graph, my function is equal to 12 at, go down, ding, it's not exactly 1.5, but if I said 1.5, I'm not necessarily going to lose marks per se, but I'm going to say around when t is equal to 1.4 seconds, and here, ding, 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 go down, bang, again, you be using your ruler, I just didn't because it's a pain to use a ruler on the iPad, so that's going to be around 8.6. So what time is the height of the tennis ball 12 meters above the ground? So t is equal to 1.4 or t is equal to 8.6. Now, you could do this algebraically, by the way, right? You could do this, I forgot to mention, but you could do this algebraically because I am given my function here. H of x equals 10t minus t squared. So h of t is my height. I'm given what my height is. Right, now, in fact, this one here is asking us to use the graph, but we could verify our answers algebraically. So the height of the graph is 12 meters. So that just means h of t equals 12 meters. Right, so therefore 12 is equal to 10t minus t squared because that is the function. Right, and what do we have here? Well, we have a quadratic. So bring everything over to one side. T squared minus 10t plus 12 is equal to 0. I don't think I can solve this one via factorizing. So let me just double check this. So if you put into your minus b formula, or whatever you may have, so that'd be, and I'm just using an online calculator because I'm being lazy. Right, 12, ding. Yeah, so if you put that into an online calculator, right? If you put that into an online calculator, or okay, you won't be having an online calculator. I put an online calculator. But if you put it into your calculator, the minus b formula, you are going to get t is equal to 8.6, and t is equal to actually 1.4. So I was off. Actually, no, I wasn't off. I'm so good at this. Right. So put that on the calculator, you can do it algebraically, and I did, and I got the exact same answer I got from my graph. Bada boom, bada bing. Right, so what's the maximum height of the tennis ball? So the maximum height, again, is the highest point the ball gets. So it's maximum here. That happens at t is equal to 5 or x equals to 5. That happens at 5 seconds. So, and then what is the maximum height? It is roughly 25. So 25 meters. That's 25 meters. So that's the maximum height. The actual maximum point will be 525. Right? And yeah, so let's look at another question now. So this one here is going to be asking us all the bits and bobs and bobs and bits and bobs. Right, so draw a graph of the function x squared minus 2x minus 3 in the domain minus 2 is less than x, which is less than 4. Then from your graph, estimate, and then we have all these questions we're going to do. So let's plot this out. Right, so we could do a little table of values, but I am not bothered. So I'm going to use my handy dandy little calculator. So my function is x squared minus 2x minus 3. And then the domain, I believe, is minus 2 to 4. So I'm going to put this right here. Minus 2 to 4. So I think it goes that. So I'm starting at minus 2. And I'm ending at 4. And I'm going to go up in ones. Right. So looking at this graph here, right? So minus 2, 5, minus 1, 0, 0, minus 3, 1, minus 4, 2, minus 3, 0, 5. Okay, grand. So I'm going to draw my little axes here. I'm going to draw an axis from 5 to minus 5. And then my x-axis is going to be minus 2 to 4. So let me get rid of my calculator here. Actually, let's get rid of it for a second. So I'm going to draw my axes. Now, I'm going to do a nice big graph, right? Make sure to draw your graphs nice and big. Right, ding, ding, ding. Right, so I want my graph nice and big. So I think I'm going to go up in twos, I think. 2, can I? 1, 2, 3, 4, 5. Yeah, I can. So I'm going to go up in twos. Now, you don't have to. But I do. Well, I'm just doing it now because I want a nice big graph because we have to use it. Right, and then minus 1, minus 1, minus 2, minus 3, minus 4, minus 5. Then 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, minus 1, minus 2, minus 3. Right, so I have my ends. Minus 4, minus 5. Don't need it, but I'm just doing it anyway. Right, let's plot out these points. Right, so my first point here is... I make this a little wee bit smaller. Yeah, there we go. Grand. So my first point is minus 2, 5. So go to minus 2 on my x-axis, go up to 5 on my y. There it is. Next one, minus 1, 0. So x is minus 1, y is 0. Gorge. 0 minus 3, 0 on the x-axis, minus 3 on the y-axis. 1 minus 4. So 1 minus 4 here. So it's 1 on the x-axis minus 4 on the y. 2 minus 3. 3, 0. 4, 5. And there we go. There is my quadratic graph. Right. So let me connect it up. I'm just going to use a different color. No, I want to use black. Bing. Bong. Sing. You don't have to use a ruler to connect these points. I'm just doing it because it's hard for me to freehand it on the tablet. Right, there you go. There's my quadratic. Bada boom, bada bing. So now let's look at the questions it is asking me for. Find the values of x for which h of x equals 3. So what is this question? Yeah, so when h of x equals to 3. So see here, I'm given a y value. I'm given a y value. So I go to 3 on my y-axis because h of x is another way of saying 3. I go across, bing, and it reaches this point and that point. So if I go down and read them, ding, and then ding, that is going to be roughly equal to, so this is minus 1, this be minus 1.5, so minus 1.6, minus 1.6, we'll say that. So x equals minus 1.6, and x will equal, so that's 3.5 here, 3.6. Again, you do have some wiggle room there. Find the value of h of 2. So h of 2, my 2 here, it's in the bracket, so it's an input. So I'm having given x value. So that means I go to 2 on my x-axis and I go down to see where it hits the graph. And it hits the graph of, I believe, right here. Bing. Bong, go across. Ding. That's going to be minus 3. So that's going to be equal to minus 3. The coordinates of the minimum point of the function. So the minimum point of the function is this point right here. This point. And then this point is going to be equal to, so read up. So my x value is 1 and my y value is minus 4. So my minimum point is going to be 1 minus 4. Now just remember, because sometimes they might give you the minimum points. They might give you a point either side. But again, and you have to kind of get the middle or the wiggle room in the middle of it. But again, it's very self-explanatory and you do have margin of error. The value of the roots of the function, so where it crosses the x-axis. Well, it crosses the x-axis at minus 1 and 3, right? We've discovered that, right? So when x is minus 1 and when x equals 3. Gorge, the values of x such that h of x is less than 0. So we are looking for where it's below the x-axis, right? And see how it's below the x-axis between these 2 points. So it's below when x equals minus 1 and when x equals 3. So what I say here is I need to write that interval. That's going to be minus 1 is less than x, which is less than 3. And that is when the function is negative. Finally, such that h of x is greater than 0. It is greater than 0 at these points and these points, right? It's above the x-axis. So that happens when x is greater than 3. So when x is 4, 5, 6, 7, 8, 9, 10, blah, 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 blah. So when x is greater than 3 and when x is less than minus 1. right? So what happens when x is greater than 3 and x is less than -1. And that is questions there on reading and interpreting graphs, right? So I hope this video was some help, and I'll catch you guys later. Bye.